Hello and welcome to this Core Pure 1 video on roots and coefficients of cubic equations. So from the work you did previously on quadratic equations, you should know that the sum of the roots of a quadratic equation, the quadratic, alpha plus beta is minus b over a, and the product of the roots is c over a. Similar pattern works for cubic equations. So if we've got ax cubed plus bx squared plus cx plus d equals 0, then the sum of the roots will be minus b over a. The product in pairs of the roots, so alpha times beta, alpha times gamma, beta times gamma, will be c over a. And all three roots multiplied together will be minus d over a. This is sometimes written, and it's a useful notation, as the sum of the alpha betas. That means the sum of the roots in pairs. That means the sum of the roots as a 3. There is only one term in that, but it is still sometimes written like that. So let's have a look at the sort of question you might get for this. And we've got the question here. Now, the first thing to look out for is if you're given an equation that has one of the terms missing. So this is a cubic, but there is no x squared term. So I would start off by writing this equation out as x cubed plus 0x squared minus px plus q equals 0. And then I would write underneath each of the values of a, b, which is 0, c, which is minus p, and d, which is q. Because this is a common trap they set in exam questions and questions in general. You need to just watch out for that. Part A says show that the sum of the roots is equal to 0. So for this, we're going to say that the sum of the roots, alpha plus beta plus gamma, is minus b over a. We can just quote that as a fact. And in this question, alpha plus beta plus gamma is going to be 0 divided by 1, which is 0. So we have shown, using the facts that we are allowed to quote, that the sum of the roots is 0. Now, let's have a look at the next section. It says, if those are the roots, find the values of p and q. We could write the equation out with those roots in and multiply everything out. So we could say, if these are the roots, then we've got x minus 2, x minus 3, x plus 5 as the 3 brackets. And we could multiply all of that out, and that would give us p and q. But actually, that's not the way that we want to proceed with this. We're going to use these facts here simply because sometimes you won't be able to use just multiplying out as a technique. So let's have a look at how we do this. What do we know about the equation? Well, we know the roots are 2, 3, and minus 5. And we know that all three roots multiplied together, so alpha times beta times gamma, is equal to minus d over a. So that's going to be minus d over a. So for this particular example, the roots are 2 and 3 and minus 5. And that's going to be minus q over 1. So this gives me minus q is equal to 30. So q is equal to 30. Right, we now need to look at the value of p. So for the value of p, we're going to look at the sum of the roots in pairs, so the sum of the alpha betas. So let's see what that's equal to. We know from what we can use up here that it's going to be c over a. A good way to remember that is that the roots taken singly is always minus b over a. That's true for a quadratic, for a cubic, and for a quartic. So it's minus b over a for taken singly. Then in pairs, it will be c over a. the sign alternates plus, minus, plus down the way. So taken in pairs, it's going to be equal to C over A, which is minus P. Let's just check here, minus P over 1. But what is the sum of the roots taken in pairs? Well, that's going to be 2 times 3 plus 2 times minus 5 plus 3 times minus 5, which is equal to 6, take away 10 is minus 4, minus 19. So we then have minus 19 is equal to minus P, so P is equal to 19. So we get our answers there. Q is 30, P is 19. Let's look now at the second cubic question that we've got here. Notice I've drawn a dotted line down the middle. That's because there's not actually very much room for this question, so you need to use both sides of the paper. So again, just compare the cubic you've been given with ax cubed plus bx squared plus cx plus d equals 0. So we know from this that a is equal to 1, b is equal to 21, c we don't know, and d is 280. We're told that the roots form an arithmetic progression. So the roots are going to be alpha, alpha plus k, and alpha plus 2k. So we've got 3 roots like that. So let's have a look at what we know about this situation. The sum of the roots, so that's going to be, the sum of the roots is going to be equal to minus b over a. So the sum of the roots is alpha plus alpha plus alpha. So that's 3 alpha plus 3k. And that's equal to minus b, which is minus 21, over a, which is 1. Dividing through by 3, we get alpha plus k is equal to minus 7. So that's one equation that we can use later on. We know that the roots taken are multiplied all together, so the sum of the alpha, beta, gammas, which is just one multiple, is going to be alpha times alpha plus k times alpha plus 2k. And we know that that's equal to minus d over a, so minus 280. Sorry, that's not very clear there. Minus 280 is what that final digit there is. So we've got 2 equations with 2 unknowns, so we need to substitute in here to simplify things. So let's see what we've got. Alpha, we can just leave as alpha. We know that alpha plus k is minus 7, so we just need to rearrange this a little bit. So alpha plus 2k, what's that equal to? Well, that is equal to alpha plus 2 times k is equal to minus 7 minus alpha. So this is equal to minus alpha minus 14. So substituting into this equation here, we've got alpha multiplied by alpha plus k, that's minus 7, multiplied by alpha plus 2k, which is minus alpha minus 14, is equal to minus 280. Multiplying all of this out and getting it onto one side, we'll get the quadratic alpha squared plus 14 alpha plus 40 equals 0. Factorising that, or using your calculator, we get that alpha is, so we're going to have plus 4 and plus 10. So alpha is minus 4 or alpha is minus 10. Now let's see what that means. Let's take first of all alpha being minus 4. If alpha is minus 4, what's k equal to? Well, minus 4 plus something is minus 7, so k is equal to minus 3. So my roots would be minus 4, minus 7, and minus 10. Let's see what happens when alpha is equal to minus 10. If alpha is minus 10, then minus 10 plus something is minus 7, so k is equal to 3. So our roots in that case would be minus 10 plus 3 minus 7 plus another 3 minus 4. So the roots come out to be the same, whichever value of alpha and k we have. So we found the roots of the equation. Find the value of c. Well, we're going to find the value of c by using the sum of the roots in pairs. So the sum of the alpha betas, so taking each root in pairs, will be equal to c over a. So filling in what we know, taking the roots in pairs, we've got minus 10 times minus 7 plus minus 10 times minus 4 plus minus 7 times minus 4. So that's taking each pair of roots. So this works out to be, when you work it out, that is going to be 138. And that's equal to c, which we don't know, over 1, because a is 1. So c is 138. So we found out the value of c. So we found out the roots. We found out the value of c. Fully factorised the equation. We're going to write here x plus 10, x plus 7, x plus 4 equals 0. So there are other ways of doing this question. You might have done it by multiplying it out from a longhand point of view, but in terms of using the facts we know about cubics, this is the method that you need to follow in order to do possibly more algebraic questions. So you need to remember with a cubic that the sum of the roots is minus b over a. The roots taken in pairs, sum of the alpha betas is c over a, and the sum of the roots taken as a 3 is minus d over a.